Greetings again, Year 9's. Making another PowerPoint for you to hopefully help you with what is probably some reasonably difficult maths on factorising or factoring, or it's called factorisation. Now you've done a little bit of it in class before you've been directed to watch this, well I hope you have, whereby you factorise just single bracket problems and put them back into their factor form. Well, what we're going to do is we're going to look at some more difficult ones, and again the whole purpose of this is if you can watch this a few times, it'll help you with your exam questions you have to do, and even watching it in class as we've done a few times this year as little reminders when you try and do the work in class. So let's have a look at our first example, shall we? Now don't worry about that 5x at the bottom. I'm having a few little animation issues here. I just can't seem to get that 5x to obey itself. It'll come in later on. Here is what you've done already in class, a binomial or two bracket expansion. When you expand it, you get that. Now, what we want to be able to do is to take this and put it back into this form, which is called factor form. So we call it factoring or factorisation. Now, it's fairly complex, but in some ways fairly simple as well. So let's have a look at what our very first step would be. We've got 4 terms. It's really difficult. If you look hard, you can't see a common factor amongst any of them. That's normal. So what we do is we do 2 terms at a time. So we put brackets around the first 2 terms, and we put brackets around this 2 terms as well. And what we can then do is we'll factorise this. Now again, I'll highlight, you should have done these sorts of problems already before you were directed to this video or this PowerPoint. So we're going to factorise this one first. Now this is when the 5x comes in here. So if you look at that, you find that the common factor here between these 2 terms is 5x. So 5x comes outside the bracket, and inside the bracket remains y plus 3. So that factorised becomes 5x outside of y plus 3. Now very importantly, look what happens when we factorise this bracket as well. Hopefully while I'm speaking you've realised, well, the common factor between these 2 terms is 2. So 2 comes outside the bracket. Now look what's raised behind inside the bracket. Y plus 3, the same as this one. Now these are what we call common factors again, and we can actually extract that common factor. So the factorised form of this up here is almost finished. It's this, but now we simplify by taking out the common factor being y plus 3. Well, they form one bracket, and the 2 terms outside here form the other bracket. So one of our brackets is actually y plus 3, and the 2 terms outside there form the other bracket. Now if you follow my purple arrow back up, you'll see we're exactly where we started. I expanded that to get that. Then when we factorise this, we ended up back where we started from. Secret being 2 sets of brackets, factorise them separately, and you get these beautiful little common factor there to do that. Let's look at some different one now that actually let's look at another one the same. Sorry, I was skipping ahead there. Let's look at another one the same, but we'll go a little bit faster. So I've got 4 terms. I'm having a look. I can't see a common factor. I've got A's there. I've got 2's, 3's, 8's, 12's. No, I can't see a common factor amongst all 4 of them. So I'll do it as 2 separate brackets. I've moved a bit faster this time. Now what we'll do is we'll factorise this bracket first, and I think I do the next one all in one. So I do the whole thing together. So if we have a quick look at it here, the common factor amongst these 2 is A, that comes outside the bracket. Left in the bracket is 2b plus 3. The common factor here is -4, that comes outside the bracket. Leaving behind again 2b plus 3. So again we have these 2 brackets that are exactly the same. Well, take out the common factor, that's one of our brackets, and the 2 outside terms here form the other bracket. A minus 4 outside of 2b plus 3, or 2b plus 3 out of a minus 4 will be perfectly alright. Now, this time we're going to look at ones that have a little shortcut to them, so they're a little bit quicker. This is what's called a perfect square. If you can't remember, this is what a perfect square looks like. It is either this way, x plus 4 all squared, which means that by itself, so you might see it written the longer way, x plus 4 outside of x plus 4. Now, when you expand it, you get 3 terms. Now, I want you to try and imagine that this is gone now. You can't see it. All you've been given is this and told to factorise it. Well, looking at for common factors just at the moment isn't going to help. So we're moving on from that little step. We have to just recognise that this is a perfect square. How do we do that? The way we do that is the fact that it has 3 terms. So it's not one of the ones we did previously. It has 3 terms. And this is the giveaway. This is a perfect square, and the last term is a perfect square. You don't need to fuss with the middle term for now. This here is a perfect square, and this here is a perfect square. So we can identify this as a perfect square. So we can factorise it really, really easily. You just draw one bracket, and all you do to get the terms that go in the bracket is you get the square root of that, which I'm hoping you're thinking right now is x. You get the square root of that, which is 4. And you put them both in the bracket. There you go. X plus 4 all squared is what goes in there, because I got the square root of x. Sorry, I got the square root of x squared, which is x. I got the square root of 16, which is 4. And of course, it's all squared. This sign here will always be the same as this sign here. So I didn't need to worry about, oh, is it x plus 4 or x minus 4? It's whatever that sign is right there. And if you look back up here, that's where we started from before we expanded. Now, I'm not going to do any more expansions anymore, but highlight again, how do I know this is a perfect square and then has that very simple square root of that, square root of that? 3 terms. This one is a perfect square. This one is a perfect square as well. So that's how we recognise that. Another common one that looks difficult but isn't is what we call a DOPS or a DOTS. Now, DOPS stands for difference of perfect squares. DOTS stands for difference of 2 squares. It depends what teacher you have, depends what textbook you look at. I've always known them as DOPS, but this has been creeping in later on. Again, let's have a look at what one looks like. So, previously we had a perfect square whereby we had 2 identical brackets. Here, we've got 2 identical brackets, but the sign is different. One is plus, one is minus, so that's where the difference comes in, the difference of perfect squares, or the difference of 2 squares. Now again, when you expand that, you get that, and I'll ask you just to ignore that now, because this is the question you're going to get on an exam, or in class. Factorise this. And your hand goes, well, where's the the common factors? Well, again, this is one of those different ones. We're not going to look for a common factor as easily as that. Is it a perfect square? No, it's not. It's only got 2 terms. Perfect squares, as we saw before, have 3 terms. This one's even easier. I've got 2 terms in it, and they are both perfect squares, which mean I can get the square root of them. So all you need is 2 brackets. One with a plus sign, one with a takeaway sign. And inside the bracket goes exactly the same things. Get the square root of that, which will be x. Get the square root of that, which will be 25. What you'll end up with is 2 brackets, x plus 5 and x minus 5. 2 identical brackets, but different signs in each. And go back up to what we started with. That's what it matches up there to. The trick for you is to recognise that. Is this a DOPS or is a perfect square? Well, you just have to remember that. If it had 4 terms, like the earlier ones, where you do it in 2 separate brackets. If it's just got 2 terms that have common factors, it's really easy. If it's got 2 terms and they're both perfect squares, it's a DOPS. If it's got 3 terms and the first term and the last term are perfect squares, well, it's a perfect square like we did earlier. Terrific. Now, next one, last one, is the hardest one, a quadratic trinomial. This does cause some people some grief. Let's have a look at what a quadratic trinomial is. You'll be given this and asked to factorise it. Now, just to get things straight now, without confusing you too much at this stage, a quadratic is any expression where the first term is squared. Now, it's a little bit more involved with that, but that'll do us for the moment. The first term is a square, so it's known as a quadratic, and you'll do these in great detail in year 10. They're a lot of fun. Yeah, ha ha ha. Alright, So I've got three terms. I can't see any common factors. Oh, it's got this, so there's already going to be an issue. Well, maybe it's a perfect square. Hang on. This is not a perfect square number. You cannot exactly get the square root of that, so it's not a perfect square. It's not a DOPS because that only has two terms, so this is what we call a quadratic trinomial. What you're going to do is you're going to put it back into two brackets, because we got this by expanding two brackets, a binomial. So, first of all, let's just draw two brackets, and you notice already I've put x in each bracket, because the square root of x squared is x, and the square root of x squared again is x, so x goes in each bracket. I got a bit mucked up there on how I was saying that. The trick is what goes in here. Now it's not the square root of that, because that's not a perfect square. Just remember, square root of that, you got x squared by multiplying x by x. Now if I was to expand this, the very first thing you do is x times x to give you x squared. So whenever you see this, you know that, well, it's going to be x as the first term in each bracket. The next part is the tricky part. We have to come up with two numbers that multiply to equal 12, this third term, and add to equal 7, the coefficient of x just there. It's got to be the same two numbers. They'll add together to equal that, multiply together to equal that. So there's a little bit of arithmetic trial and error with you. This is what you're trying to find. What number plus what number equals 7, but the same two numbers multiply to equal 12. You can try a few numbers in your head, the 6s, the 1s and all that. Eventually, hopefully you would come to the conclusion that it's 4 and 3. 4 plus 3 equals 7, and 4 times 3 equals 12. These two numbers, 4 and 3, are what actually go in here now. They're the second terms in your brackets. Okay? So the actual factorisation of this quadratic trinomial by the multiply to equal that and add to equal that ends up being x plus 4 outside of x plus 3, or if you wrote it the other way, x plus 3 outside, x plus 3 outside of x plus 4, that wouldn't matter. Again, the trick to it is multiply together to equal 12, add together to equal 7. Look, that's some pretty tricky algebra. Hopefully this helps you.